what we're looking at, but also a little awful at the same time. So here, up top, there's a histogram. This does not include you guys, of course, because you just turn your stuff in right now. But this is a histogram. Let me kill the lights so you can see exactly why I'm pointing this at you. We've got 3 histograms there. Remember how I had you do 3 different calculations on that project? The first thing you had to do, this is the last 6 points of the project. So this is one where you had to go open the rectangles, look at them for 10 seconds. Does anybody have a flashback to 243 with the Inigo Montoya speech? Maybe? Yeah, figure out how many average length words. Yeah. So, same thing. So up there, you see a blue histogram, which is the guesses that students have had in the past when I give them 10 seconds to guess. Then, we see the red, which is the Your Choice 5. The Your Choice 5. That's the one where I say, you guys pick 5 rectangles that you think are representative samples, average those. And the green one back there is the Random Choice 5, where I actually have you grab the random numbers and calculate the averages there. So can you kind of see what's going on? I didn't know the best way to do this. A 3-dimensional histogram isn't ideal, no problem, but it is, I think, the best way of looking at 3 simultaneous histograms. So comment, friends, from blue, which is the 10-second guess, to red, which is the Your Choice 5, to green, which is the random number generation. Comment on the shape of these curves. Comment on the location of these curves. What do you think's happening? Sure, it's in a named example, because who cares about rectangles? But comment. What do you notice? What do you notice? Anything at all? It's Thursday. I'm not letting you off easy today.
Bell shape.
Go, Jack! Boom! We got some cool bell shapes! One of those I would expect. Can anybody guess the one I would expect to be bell-shaped? Actually, the Your Choice 5, I have no way of knowing what you're going to choose. Although, I like your guess of Your Choice 5, because as we learned in 243, so many things are bell-shaped without really knowing why. And maybe there's some little markers that we all share that we're all flip-flopping back and forth like the Plinko balls dropping into the grid. So Your Choice 5, I could argue that one. What one would I totally expect to be bell-shaped? Yeah, and it's the least bell-shaped looking one, kinda. But yeah, Chris, I would go with the green one being the only one that I would guarantee being bell-shaped because I forced you guys to use a randomizer. So it's the only one where truly randomness actually happens. What's interesting though is you get a bell shape amongst almost every single one of them, which is kind of tricky. Okay, talk about that. No problem. Talk about the locations, friends. Which one has the highest average? Which one of those 3 data sets has the highest average? Go for the middle one, Rosie. Why? Or whoever that was, Dina, whoever that was. I heard a voice over here.
8 to 9.
Oh, you're going for Mo. Okay, beautiful, beautiful. So 8 or 9. You guys definitely, when you choose, when you do the Your Choice 5, you're choosing 8 or 9 almost inevitably. And I say you guys. The class is up to, but not including you guys. Yeah, I'll get that your data in here too as well. Good, good. I like that. What's interesting about the right side of the Your Choice 5 and the 10-second guess?
Above 13.
Can you guys see that above 13 bar?
Yeah.
It's ridiculous. Like you have this perfect bell curve and then boom! And I think I have an explanation for that has nothing to do at all with the experiment. I think some folks get a little confused by my instructions. I tell them to use the randomizer to generate 5 random numbers from, I think it's 1 to 100, right? I think sometimes people actually average the numbers that come out of the TI. So for example, if it says, if your randomizer goes 1, 2, 56, 97, 98, they'll average 1, 2, 56, 97, 98, instead of going and finding rectangles 1, 2, 56. You see what I'm saying? I'm guessing that's what's going on over there. Because if you look at that image, there's no rectangle in the image bigger than 18. I think 3 by 6 was the largest one. So there's no way the average could be above 18 unless you somehow misread the directions or did the math, I guess. Tell me about the averages of the blue and the red curves versus the averages of the yellow or the green ones. The averages of the blue and the red. And I'm going to argue, if it's okay with you guys, that the average of the blue and the red is basically the same. It might not be. It might not be exactly the same. I'm going to argue that it's essentially the same only because They both spike at the same, and they both have a set of outliers. Blue has more outliers than red. So I think whatever blue lacks in average in the middle, it makes up for the outliers, if that's fair with you guys. So comment, let's assume that blue and red have the same average. Tell me how green is different, average-wise.
No, green has a smaller average.
It's got a smaller average.
Eric.
It's Eric. I was going to say Eric. That's what I guess.
10 times the
I know. And as soon as I asked you, Eric popped through my mind. I was okay. So we got you now. We got Eric. We got Eric. Green has a smaller average, which means that on average, what are my students doing? When I'm asking them to estimate the average of the rectangles, they are overestimating, right? They're overestimating the average. Why would you think they would be overestimating the average? This is an interesting question. It goes to the idea of bias, which is the point of the whole project, really, was how to avoid bias. Eric?
There's those big blocks everywhere, and then there's like a lot of small ones, but you just kind of notice.
You look
When?
past the singles.
Sorry.
You look past the single ones.
Exactly, Kaylee, exactly. You look past the little tiny one-by-ones. I encourage you, go back and look at that image again. There are tons of one-by-one squares tucked up in the left corner. But your eyes miss that. Your eyes go to the big ones because they take up 18 times the amount of space. Same thing as Inigo Montoya in 243, when I asked you to average the length of a word in his speech. Everybody says things like 7 letters, 8 letters, 9 letters. It actually is 4 letters. And when you think about The Princess Bride, "You kill my father, prepare to die. My name is Inigo Montoya." There's so many little words that are 1 and 2 letters long, and each one of those counts just as much as slaughtered, finger, right? All those words count once. Just like all these rectangles count once, and they cancel each other out and end up more towards the middle. And that's what I think is going on here, which is why we like to randomize data. We like to randomize data because only by randomization can we ensure that we're not allowing any bias into the analysis of our data. Does that make sense? You guys buying that? And I think it's interesting. Happens every term. I'll add your guys' data in, and if I can remember, I'll bring it back on Tuesday, but I fear that you won't care by then. And that's okay. It's okay to not care. At least you can see this. This happens. The curves don't change much each term. They pretty much stay exactly the same. You'll notice that occasionally there'll be an absent data point in the data list. So here is the 10-second guess. That's the your pick 5, and this is the random choice 5. Every once in a while, I'll have a number removed. That's because the number that a student wrote down could not possibly have been correct. Like it'll be like 1,268. I'm like, okay. But that's an outlier that doesn't make any sense at all. I'm thinking they fell asleep doing their homework. So I'll just take out like outliers that are clearly data entry errors. And I'll include ones that might be outliers that are legitimate outliers. Rosie?
I think it's funny because in my guess, I guessed low
Mm-hmm.
on the first one because of the fact that I saw all the ones.
Oh, so your eyes were going to the small
Like,
ones.
I was like, oh, 5 because these are outliers.
Interesting. So you guys went right to, oh, cool. How many of you did that? How many of you noticed the little guys? How many of you didn't notice anything different between the little guys and the big guys? I don't know how to ask this question. It's going to be a weird question. Yeah, so it seems like this side of the room noticed the little tiny rectangles. There's a correlation there. This underestimate averages sit on the right side of the classrooms. Potential publication right here. Or retire. Did anybody think twice about it, or you just kind of go like, 7? That's what I wanted you to do. 8. Kind of like when the government deals with budgets. 2 trillion. Essentially. So that's what I wanted you to do, at least for the first. For the second one, I wanted you to go through and pick. What was your method for the Your Choice 5? Do you guys have a method for the Your Choice 5? Anybody pick up like 5 pennies, throw them in the air, drop, and then pick those 5 rectangles? That'd be kind of random, actually, more than Your Choice. But yeah.
I just picked a couple little ones and a couple big ones, and
Yeah.
one in the middle.
What did your average come up to be, Eric? Do you remember?
It was like 6.8 or.
The average is 7.1. Believe it or not, the average, if you actually add up all those rectangles and divide by 100, it's 7.1. So pretty rad, actually, that you got that close by kind of picking the outliers and letting the middle find the middle. You're assuming a bit of a uniform distribution there, which is fair because it is. But in general, you want to be more random. But that's good. That's really
I had
good.
no idea. I was just
No, it's pain. That was the point. The point wasn't to tell you what to do. The point was to see what you did and then put it together and take a look at the whole thing, which is kind of the point of statistics. Let's not do something that we know the result of. Let's collect something and see what we see. That's kind of like the point, I think, anyway. Please, Justine.
My Your Choice 5 and my Random Choice 5 come out to be the same.
The same number. And good. That's phenomenal. the random choice 5 sometimes is quote unquote wrong. Did you notice that? Random choice 5 is green. Sometimes the random choice 5 puts you out here at 11 to 12. I mean, it's not that random choice 5 is always the best. It's that on average it's better. Does that make sense? You're not all, and this is the problem with America. Well, one of the problems with being American is that we are so used to things happening exactly the same way every time, we don't know how to deal with variation. This is why confidence intervals, this is why the concept of standard deviation is so tricky for American students to get. You learn what an average is. Remember when the first time you ever learned what an average is? Remember what grade it was? I can predict it was in 7th, if not before. If not before, it was probably around 7th grade. Remember what grade you first learned standard deviation in?
Never.
What grade?
College.
Cassie Moore.
I never read it until this class.
Oh, I was going to say, never. Cassie Moore, I believe I had you in 243.
No, I
see.
until this class.
So basically, you go from 7th grade all the way through the remainder of middle school, through high school, through the beginning of college. Then you talk about variation. In that 6, 7, 8-year period, whatever it is, you spend your entire life talking about an average. You spend your entire life talking about that number, and that number, and never talking about the rest of them that make up the entire distribution. And it's no wonder that students can't comprehend what a confidence interval is off the bat. You guys are getting there. I'm excited. You're getting there. It's great. I mean, you're starting to actually get the idea of spreading data and how you can minimize the spread of that data. But we never talk about it until college. That's a crime. That's a crime. So that's why I keep inundating it. Pretty much this entire course, if nothing else, is a study of margins of error. Honestly, it really is. I mean, yeah, there's an average in the middle of all the intervals, but it's really how far out does the spread go? And are we in or are we out of it? I just got done putting together 95%-ish of your take-home exam for next week. Oh, no, it's a good one. It's a good one. It's a lot of circle. I think it's good. I think it's great. Look at unemployment rates, looking at drug results, Lipitor.
Depressing.
What's that?
That's depressing.
Well, it depends. Are they going down? Are they going down? See, this is that's what we're going to analyze. You see, when we say I'm sure they're going up, that's because we're used to the news reporting on negative stuff. If we go straight to the source of the data, we can see if they're going up or going down. That's why I can come in here smiling all the time. If I watch the news, it depresses the hell out of me. I ignore the news and go straight to the data and let the data tell me a story. And then if the data is showing me a story I don't necessarily like, I'm going to track that and see if it changes over time. That's the beauty of this course. The beauty of this course is watching these curves kind of do their dance and see what it's telling me. If it's telling me anything. Sometimes it doesn't tell me anything. That's some of the things we can't conclude anything. But sometimes it does tell me something, and that's kind of the point of the course. That makes sense? So anyway, really this course is nothing more than a study in variation. I mean, honestly, if you were to break it down to one big idea, it's making sure you understand what a margin of error is. 243 was all about the average, honestly. We spent so much time with averages, and towards the end we got into the whole idea of standard errors and margins of error. But really, this is the course that drives that point home. If you remember, if you took me for 243, I snuck some 244 in from time to time. I would sneak in the idea of margin of error. That we do variation, margin of error. We do outliers, margin of error. Binomial, margin of error. Central limit theorem, standard error. I kept sneaking it in. But the reason was I didn't want anybody leaving 243 to never use that term conversationally. To understand that you can have a plus or minus. You have to have a plus or minus around something. Yeah? So that was 6 points of the how was the other 75% of the project, okay? Just terms. Really is all it is terms. And some critical thinking about how studies were done wrong. Or at least how questions are posed the wrong way. This is not to imply that every question that is posed is a bad one. It's to pose that some of these questions are ludicrous and they keep happening over and over again. So, cool? Awesome. Rainy day coupon. You may have noticed on the project it says, don't forget the rainy day coupon if needed. If anybody walked in here and hears me talking about a project, is like, what the hell is he talking about, a project? That means you probably didn't do it. If you forget to do a project at any point, I have 4 of them in the class, you have 3 more of these. If you forget to do one on the due date, you can print that coupon out, staple to the project, and turn it in up to 24 hours late, no penalty. If you don't use that coupon, it's worth 5 extra points to you, which is why so many of you had over 100% on the first couple progress reports, because you had 5 extra points added to your point total. And right now, you only have about 30 points at your point total. So 5 points over is significant. It's significant. It's like 17% of your grade. It gets less as time goes on, but it's still extra credit. So everybody keeps that 5 until they use the coupon. Most students don't. Yeah, Rosie?
I was wondering, we were in, Donna's.
Yeah, for sure.
And she pounded in our head the rare event rule over
Uh-huh.
and over and over again. And
I-
said how it was gonna be a big deal in 244. So I'm wondering how.
Potato.
Okay, that's what.
Believe
margin
it or
of
not.
error,
Yeah,
it's the same
I
thing.
like to use the phrase margin of error in confidence
Okay.
because the rare event rule is never used outside of school classrooms.
Okay.
If that makes sense.
No.
I try to use language that you actually see in the media and the news. And the rare event rule is important, but statistics textbook writers love it.
Okay.
And we're going to keep using the idea, as a matter of fact, today, we get into actually formally defining it. And I'll mention that when we get to where it would be called the rare, I'll point to it and say, this is what she was talking about.
Alright.
And you'll probably would have recognized it at that point too. So yeah, it's for sure there. It's how we make decisions. But I try to use other words like significant difference, or it has changed, or it has not changed, or things like that. So yeah, it's definitely there. And that's, honestly, potato, potato. It's all sort of the same thing, for sure. Cool? Good. Good, good, good. Let's start and stop this thing again.